in geometry you learned on ways to prove that triangles were congruent, like angle side angle and angle angle side. Probably don't have many memories of this, but you really did. The law of sines, you have to know similar things to be able to do this. So if you know two angles and any side, so if you know angle angle side, that's enough information that you can use law of sines. Skip this one for a minute. If you know three sides, side, 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 then you can use law of sines to find the rest of the missing angles. If you know two sides and the angle in between them, that is side, angle, side. Those are all things that you did proofs with those, and you would end with side, angle, side, triangle congruence theorem. I don't know if you remember that or not. But there was one that you were not allowed to use, and that was if you had two sides at an opposite angle, which means like two sides and then the angle opposite over here, maybe. That would be side, side, angle. In geometry, this did not work because it spells a bad word, and that's what I used to teach my students when I taught geometry. You don't want to write this on your paper because you don't want to turn a paper in with a bad word on it, and every year people did because they didn't remember. And they didn't even realize they were writing it. They were just writing angle, side, side. We're going to talk about that we can still do law of sines with side, side, angle, but it's tricky, and sometimes it works and sometimes it doesn't work. So I call that the asterisk on these because it's a special case. But the law of sines is basically just this proportion saying that you can relate the sine of an angle with its side comparing to the other one. So here you go. Here's the law of sines. So that's it. That one thing there. Law of sines. I'm sure that's the law of sines. Notice that the lowercase letters are the side lengths and the uppercase letters are the angles, and the angles have to go with sine because we take the sine of angles. But you can relate any side over the sine of the angle across from it and compare it to any side over the side of another angle. So we say that A over sine of A is equal to B over sine of B, which is equal to C over sine of C. Now when you solve a problem, you don't need two equal signs. You're only going to use two of these at a time, and I'll show you what I mean by that. But they're all equal to each other. And we like to say, or the reciprocals, because this is just a proportion. If you pick two of these, so depending on what you're solving for, you might want to flip it over. So that's the same as saying, I don't know if you want to write this out, but that's the same as saying sine of A over A equals sine of B over B, which equals sine of C over C. And we'll talk about in a minute why we would want to flip it over, depending on what we're solving for. I'm not making you memorize this. I don't think it's hard to memorize, but it's on my sheet that I give you, so you just have to know how to use it. Okay? New one. Definitely some calculator active problems tonight, which means you want to have a calculator that has sine on it. If you don't have one, if you have a smartphone, you should have one on there. If you have a computer, you should have one. Or if you really don't have one and you want to borrow one of mine, just make sure you let me know so I can write it down so I'm not freaking out when I'm missing 7 calculators at the end of the day. Because you're going to need a calculator to do these problems. The directions here say solve the triangle. Do you remember what that means when it says solve the triangle? What did I say? Solve the triangle means find every part that's missing. How many parts are there to a triangle? 6. There are 3 sides and 3 angles, and every time they're going to give you 3 things, which means if it says solve the triangle, there are going to be 3 missing parts that you have to find. Okay? I like to label my triangle. I drew this triangle. You can draw whatever you want. If you want to draw a right triangle, draw a right triangle. Just don't label a 90-degree angle because there's not a 90-degree angle here. I drew this one, and I would probably label this as angle A just because it looks bigger than 90 degrees. But the picture's just there to help you put the sides and angles together. If your picture is not drawn to scale, guess what? No one cares. You're going to see a picture of mine in a minute. It's going to be terrible, and the acute angle is going to be labeled as an obtuse angle, and it's okay. As long as you label the angle and the side across from the angle better be labeled with little a. That's what matters. I'm going to go ahead and call this 102.4 degrees. Does it matter if I call this angle B or this angle C? It doesn't matter as long as the side across from angle B is little b and the side across from angle C is little So don't freak out about the picture. It's just there to help you. On this one, they give me two angles and a side, which would be angle, angle, side. That's one of the things I said works. If you need to find everything else that's missing, what could you find right now? Which part of the triangle could we find that we, without even using all signs, like what else could we find? Angle B, because what do we know about the angles in a triangle, or what should we know about the angles in a triangle? They add up to 180. So if they give you two angles, the easiest point to earn is to say that you know angle B is 180 degrees minus 102.4 minus 21.6. Do you have to write that on your paper? No. And I'm just writing it in our notes. 21.6. Sorry, thanks. 16.7. 180 minus 102.4 minus 16.7 means that angle B is 60.9 degrees. So even if I knew nothing else, I could at least solve for the other angle in this one. Now, what else am I missing? I'm missing the two sides. I'm missing little b and little c. You cannot try to do Pythagorean theorem here because it's not a right angle. Pythagorean theorem only works with right angles. You cannot do SOHCAHTOA. SOHCAHTOA only works with right angles. But what we can do is we can use the law of sines. If they give me angle A and side A and angle C, could we say the A over the sine of A equals C over the sine of C? Is that part of the law of sines that we wrote out? Yes, we're just leaving B out because we don't know B right now. You only need two of them. And all you have to do every time they're going to give you three things, plug in the three things they give you, and you're just going to solve that proportion basically. So you would get 21.6 over the sine of 102.4 degrees is equal to C over the sine of 16.7 degrees. And there's lots of ways you can solve this problem, but you definitely need a calculator. It's important that you type things in your calculator correctly. Anybody who need a calculator, want me to throw them a calculator? Feeling safe today? Ellen's not feeling safe.
Anyone else?
The thing broke off my hand, and it was like... So, a couple ways you can do this. One way you can do it is I feel like I was always taught if I see a fraction equal to a fraction, I could cross multiply, and I could take this times this equals this times this, right? And that always works, and it still works. I was teaching this, one of my first years teaching Precalculus, I was teaching this, and I had a foreign exchange student from Thailand, I think, and he said, why would you do that? Why wouldn't you just multiply by sine of 16.7, and then you do it all at once, right? Like that goes away, because when you cross multiply, it still works, but when you cross multiply, then you still have to divide over, you see what I'm saying? Cross multiply all you want, I promise it works, but I just felt stupid that I didn't even think about that I always just cross multiplied. But he says, why cross multiply when you can just multiply this over, and then you can do this all on your calculator at once? So I'd just like to enlighten you the way I was enlightened a few years ago. Colin decided he likes cross multiplying, and he's going to continue to cross multiply, and I'm okay with that. I'm just like to show you, oh, I never thought of that. I was brainwashed to cross multiply. I know, and it works. It's just an extra step, basically.
I forget how much.
If you just type in this times this divided by this, it should all work as long as you close your parentheses after 16.7. If you want to do this first, someone in second hour said, why would you do that? Why wouldn't you just do this on your calculator and then multiply that over? It's the same thing, no matter which order you do it in, as long as you're multiplying it correctly. I just typed it in all at once. In degree mode, I'm just going to type in sine of 16.7, close my parentheses, times 21.6, divided by the sine of 102.4, which is exactly what you do if you cross multiply. And just round to one decimal here, I get 6.4. You want to check that you're getting the same thing? You did not get 6.4? Hold on, I'll be right back there. The last one we have left to find is side B. Don't do Pythagorean theorem, but do the same thing. do A over sine of A, but now do B over sine of B, and see if you can get side B as well. So just a whole lot of calculator work. Why are you? Anyone else think calculator? You could use C over sine of C also. I just always use what they give me in case I made a mistake. I stick with the A's. So I'm going to do 21.6 over sine of 102.4 degrees equals B over sine of B, which we found to be 60.9 degrees. I don't care if this is the work you show me and then you just say B equals. I'm okay with that. Because every time you're just going to multiply that over. But the important part is that you're using your calculator correctly, because if you don't type it in correctly, you're not going to get the right answer. Sine of 60.9. 19.3. Did you get that? How can you at least hope that your answer is reasonable? Remember that the biggest angle is always across from the biggest side, and the smallest angle is across from the smallest side. So when I take a test, I always make sure that my answers at least match that. 102 is the biggest angle, so side A should be the biggest, and it is. Angle C is the smallest angle, so side C should be the smallest side, and it is. And so I feel better about my answer when I'm doing that. Does that make sense? So 3 answers that you have here.
Do we have to memorize all of them?
No, I'm giving it to you. It's not that hard to memorize, but you don't have to memorize it.
Yeah.
So what makes this more difficult is that angle side side. It's a real pain.
It sounds like a
We'll see. We can get through this. They call this the ambiguous case because when you have side-side angle, I'm never going to write it angle side-side. I like to say angle side-side, but I'm not going to write it that way.
why not?
Because what if Mr. Puckett walked in and I just have that on the board?
So it can't be as bad as
It's called ambiguous because we don't know what's going to happen. Sometimes it works just like we just did and we get a perfect little triangle. But sometimes you get no triangle and sometimes you get 2 triangles. And so you have to kind of just work it out and see what's going to happen. And so you don't have to really write if given 2 sides and 1 opposite angle. You could just say it could be no triangle, 1 triangle, and 2 triangles. How do you know? You have to just work it out. The pain is when there's 2 triangles, it's like 2 for 1 problem. Oh my goodness, how exciting is that? Because you have to find both triangles. The happy part is when there's no triangle because you realize there's no triangle and you don't have to keep going. So, and then the one in the middle is just like a normal one. But you got to look for it. Angle, side, side. When you see that, you have to check for it. I believe your homework tells you which ones are angle, side, side. I don't think I'm as nice on the test to tell you which ones are angle, side, side. Okay, so guess what? We have 3 more problems to do because there's 3 cases that I want you to see. You want to start with the worst one or the best one? That's what I have, the worst one next. People are so on the same page here. Can I go?
Can you wait like 15 seconds?
Yeah, but this is prone, sure.
Oh, with the bad word in it, right?
Oh, it was a string of bad words.
It's alright, I still don't want to. I can't bring myself to do it.
There's
But
a couple of F-bombs.
every time I graded geometry test and someone wrote angle side side on it, I always just circled it like look what you wrote on your test.
Awesome.
Again, I don't know why I kept these on there. I could just randomly draw my own. Notice that my picture here, my pictures tend to always look like an isosceles or equilateral triangle. And again, my picture is just there for me to visualize it. Your picture does not have to match up to actual angles. I hope you learned that in geometry class. Pictures not drawn to scale.
Drawing
So I just label ABC, and I'm going to say that this is 58 degrees. I know this is 11.4, and I know this is 12.8. Just helps me see what I have and what I need to find. Notice that I have angle side side here. So step one, we can't just find the other angles like we did in the last one. You actually have to start with the wall of sines. And the only thing you can find, if they give you angle A and sine B, what's the only thing you can find right now? Angle B, because you have to set up and use the sine of A over A and the sine of B over B. And notice, since I'm actually looking for the angle now, this is where I think the reciprocals come in handy. So since I'm solving for angle B, I like to flip it over now and say side B over B equals sine A over A. You don't have to do it that way, but that way you just have to multiply that over. That's why I like to do it. So that's why I flip it over. So I'm going to say the sine of B over 12.8 equals the sine of 58 degrees over 11.4. And again, using the cross-multiplying way, if I'm just solving for this, the reason I like when it's on top is I just have to multiply by 12.8. Whereas if sine of B was on the bottom, you'd have to either cross-multiply or multiply it over. But the difference is we're solving for an angle here. So I don't get B right now. I get sine of B equals this lovely, ugly mess. So I have to type in the sine of 58 degrees divided by 11.4 times 12.8. And you get like 0.95219. Write a good amount of decimals there. Hopefully you don't make the mistake and tell me that that's what B equals, because sometimes people do. B shouldn't be an angle less than 1. I think that's kind of a weird angle to have. That's what sine of B equals. So do you remember what we do to actually find B? Inverse sine. So on my calculator, I'm going to do inverse sine of that number, and I get 72.2 degrees. Yes, but wait, there's more.
Sound like Billy Gates.
Here's the ambiguous case part. When you're solving this, let's just pretend. What if it said sine of B equals 1/2? What would you tell me? What would you tell me the angle was if sine of B equals 1/2? 30 degrees. You would say B equals 30 degrees. And I would say, is that the only place where sine equals 1/2? And you would say, no, because sine is positive in quadrant 1 and quadrant 2, which means there's another angle that has that same sine value. Yes? Is the same apply to this ugly one? If sine of B equals this at 72.2 degrees, is there another angle in quadrant 2 that has this same sine value? Always. There's always two trig values. So when you're solving for an angle, you have to see what the other angle is. So if this is 72.2 degrees, I know that in quadrant 2, there's another angle. Here's where the trig comes back. 72.2 degrees that has the same reference angle, right? I want to know, how do I go from 0 to that line? What would I do? This part 72.2, how would I figure out how far it is up to that line? So another option for B is 180 minus 72.2. And since the law of sines only has sine in it, do you agree that's what you'll do every time? Because every time you'll be over in quadrant 2.
Can you just add no degrees to say?
Does that give you the same answer? I don't think it does. It doesn't give the same answer. It seems like it should work, but I don't think it works. So that means B could also be, I believe, 107.8 degrees. Because when you have angle side side, it's so little information that these other two angles and the other two sides could open up and be an obtuse angle, or it could be an acute angle. And that's where the two cases come into play. Now, how could it be not true? What do we know about a triangle? How many degrees are in the triangle? 180. What if this would have turned out to be like 160 degrees? Could we have a triangle if this was 160 and this was 58? No. So if you do this and you get a really big number that when you put it with the other angle it's bigger than 180, that's how you get no triangle, or maybe only one triangle. So you have to really think about that as you do it, and I'm sure we'll talk about this more tomorrow. But this is an example of two triangles. Now you got to solve it all. So Colton, that's where now you're right. Now we can kind of do two problems in one. Now we can find angle C for both of these. And then we can find the other missing side for both of them. And we're going to do one more. Just hold on just a second. Maybe. We're running out of time. How do we know if it works? When you find angle C, that's kind of how you know. If you take 58 and 72 and you subtract from 180, you're going to get a third side for that triangle, or a third angle, right? 58 minus 72.2. This one you get 49.8 degrees. That's a triangle. That's good. What about on this one? Does it work? If you add 107 plus 58, can you still subtract from 180 and get another angle? Yes, you can. It's a very small angle, but it's 14.2 degrees. If you would have added A and B together and then subtracted and got a negative angle for C, can you have a negative angle in your triangle? No. That's how you throw it out and you say then there's no second triangle because it's too big. It doesn't add up to 180. And then to find the third side, I want to kind of maybe speed this up a little bit. For side C, now I'm just going to do the same thing I did before. C over sine of 49.8 degrees equals, I'm going to use A again, 11.4 over sine of 58 degrees. Of course, when I say speed things up, my smartboard decides to stop writing. And you could solve that and get what C is. Yes? There are really good examples in your book. I know you most of the time don't read your book, but you paid a lot of money for it. You really should look back at it sometimes if you have trouble. But I think you get 10.3 here. You're going to do the same thing on this side. The only difference is now you're going to use 14.2 instead of 49.8. Which is why I said so much of this homework is just calculator stuff and knowing the formula.
How do you know if it's like if there's two triangles or three triangles?
There's never three triangles, right?
There was.
There's 0, 1, or 2. Okay, so two triangles is this. This is as bad as it can get today. It's two triangles, which is why we started with this. Which means we have three things that we're finding for two triangles. An angle B, an angle C, and a side C for two triangles. If there was only one triangle, I don't think we're getting to that problem today. But if there was only one triangle, let's say we would have solved this side, and let's say B would have equaled 167 degrees. If we tried to find angle C, where we had 58 degrees and 167 degrees, we would have had a negative one. And if it was negative, we would say, you can't have a negative angle. That's out. So that's how you get one triangle. Okay? Anytime you do inverse sine, you got to check. All right? Check for the two triangles. How could you get no triangle? I'm always ecstatic when I get no triangle because it means I don't have to do all that work. Angle side side is the only time that it could be no triangle. The thing is, you can't just look at this problem and tell me it's no triangle. You have to actually do a step first. I will tell you that there are problems on your homework tonight that the directions say, just say, is there one triangle, two triangles, or no triangle? That means once you figure it out, you can stop and just say 1, 2, or none, but you can't tell just by looking. Right? You have to do one step. And the first step is label your picture, and again, it doesn't matter if it doesn't really work with it. Just label it. Like, let's see, B is 25. Just like the last one, if they give you angle side side, there's only one place to start. You have to start with the other angle that they don't give you with the side, right? That's the only thing you can do. So I'm going to say sine of B over 25 equals sine of 85 degrees over 15. I think that's right. Wouldn't that be better if I just made that up? Oh, no, it's 1.660. Sorry about that.
Yeah, gotcha.
I was just trying to go from second hour memory. I was pretty close from just remembering the answer. If you don't remember what this means, you can use your calculator. But can sine ever be 1.6? Between 1 and negative 1, right? And if you forget that and you try it on your calculator, it's going to say error, so it's going to remind you. You can't do this, which means can you make a triangle that has this angle, this side, and this side? That's why in geometry it was a big no-no to do angle side side, because sometimes it makes no triangle. And the answer here, there is no triangle that is formed with those answers, which means you get to move on when there's no triangle. That's the answer. So that part is the one we did first. Sometimes you're going to have two triangles. You have to work them all out, type a lot of stuff in your calculator. But the big part I want you to get today is make sure you check for the second triangle if it does work. All right, we'll definitely talk about this tomorrow. We're going to do another day, add in some area formulas tomorrow with this maybe. Had one, this was an example of one triangle, but we just are out of time. This is 5, day 1. Make sure you read the directions. On the ones that just say how many triangles are formed, you're going to be really mad tomorrow when you worked it all out and all you had to say was 2 triangles from that first step. You can tell from that first step when you solve for your 2 angles whether it's 1, none, or 0. So that's all you have to do to answer those. But there are some that you need to work out. Definitely check your answers in the back, and we'll talk about these tomorrow and then finish up 5. Look in your book. Your book has really good examples. There's like step by step in there. I feel like I should be teaching you to look in your book more than I do.